Hello, my name is Michael Samuel Webb, and in this Lab 3 tutorial we're going to be starting in our GPT disk management, our graphical user interface disk partition disk manager area to create a volume of 5 gigabytes into this disk here. So we're going to just create a new simple volume of 5 gigs. NTFS file system. Okay, now we're going to extend this volume by 4 gigs. So 4 plus 5 is 9. Gigs. Alright, now we are going to shrink the volume by 2. Alright, now we're going to create a span volume by extending the simple volume by another 5 gigabytes onto. So we're going to take this unallocated space here, or actually we'll just come down here and we will create a new span. And we're going to expand it 5 gigs onto another disk. Let's just use disk 1, and we'll take disk 2, and we'll expand it 5 gigs. NTF, we want a quick format. So it's telling us that it's going to create it and it's going to convert it into a dynamic filing system. Okay, as we can see down here, unallocated, primary, simple, and spanned. There's our span volume from disk 1, 5 gigs over into the second disk. I'm going to look up here. Now our E and F volume that's spanned over into our second disk is dynamic from basic, and it tells us our layout from simple to span. To delete the volume, I'm going to go ahead and delete this volume. Now we have totally unallocated disk space to work with. Now we see everything is back to basic, and actually this is unallocated. If I had left it, it would have been a dynamic type. Now we are going to create a mirror using all the space on disk 1 and disk 2. NTFS, want to be as fast as possible. Just going to leave it as new volume. It's dynamic disk. It converts it into a dynamic disk, except we can't load anything onto it except for the boot volume that's already on our system reserved allocated space here. We get the mirrored color from our bottom definition here. We can remove, break, format, change, drives, delete, and that's pretty much it. There's no way of expanding these mirrors. There's no extending, no shrinking. So now we're going to break the mirror volume. And it takes us back to, drops us back down to simple volume. Format. Just going to go ahead and delete that. Delete this volume. Okay, we're back to just normal unallocated space. Now we're going to create a RAD5 volume. And we're going to use 1, 2, 3 disks. We're going to use all the space. They're all 10 gigabytes apiece. Let's call it new volume. NTFS. Converting it back into a dynamic. And there we are, they're resynchronizing and creating. Up here we have our E1 dynamic volume, which you have to have 3 volumes in order to create the RAD5 volume, simply because of the way that it stripes and uses the data inside of these partitions of however it is that you're going to use them, and creates backups and mirrors. So you'd have to have at least 3 for RAD5. There is no way to repair these without using some type of an outside source through PowerShell. I'm going to delete these. Okay. Back from dynamic, it just took us straight out of the RAD5 into the unallocated. And that's it for lab exercise 2. And again, the repair option can be done through PowerShell to take a corrupted allocated disk and use software, a third-party software in PowerShell to repair it and put it back onto a second disk if you were to have a RAD5 corrupted disk. So that's it for the lab exercise 1. On to 2. We are going to create a storage pool, and we're going to add 3 of these disks. So in order to do this, close here, and we're going to open and we are going to open our server manager. And we're going to go to our local server. File storage services, storage pools. We're going to create a storage pool. I'm going to name it pool. We're going to use disks 3, 4, and 5. Leave the allocation to automatic. And close. We're going to create a mirror using all the available space. After we create a 5 gig virtual drive, I call it 5 gig. I'm going to create this mirror, which you have to have against it. It gives you have to have two disks in place in order to create your mirror. We're going to use a thin provisioning. It's going to be 5 gigs. We're going to look inside here, and we see our 5 gig mirrored pool here, and we're going to create a volume using all the space. It's 5 gigs NTFS. And there's our new volume. with our new technology file system, file management. As you can see, we can see our disk 4. We used 2, 3, and 4 in order to create this mirrored disk. We can't see it because when creating, it basically shows us it's mirrored to here's your 1 in order to set up your volumes and do whatever it is that you're going to do with the disk. We look at our properties. It shows how much room we have here. Go here to our properties. It shows us what we have here: used, allocated. Okay. Now we're going to detach our mirror virtual disk. We know it's detached because it gives us a little symbol here letting us know. And now we're going to create a parity virtual drive within. So we're going to delete this virtual disk. Which, in order to do that, you must detach it. This time we're going to use parity. You have to have at least 3 disks in order to use this one, opposed to using at least 2 disks on this one. And these layouts are to increase the reliability, which parity provides the best as far as it increases your reliability, but it somewhat reduces performance. We're going to use thin because we only want to use the volume, allow it to use the volume size as needed. 5 gigs. Create. We're going to create a simple volume of 5 gigs inside of our parity here. in this case, for this parity, we didn't have to tell it what discs that we were going to use, is because we had 3 already set in our pool to use. If we had only had 2, it would have given us an error message saying that there isn't enough space, or there isn't enough discs in order to create a parity file system. We've created our volume of 5, and we are using our new technology filing system, NTFS. Everything's still basic. Now we're going to extend the volume. We're now going to extend our volume, our parity thin provisioning 5 gig capacity. We're going to extend this one to 50 gigs. And we are able to do that because, say we only had 5 gigs, well, it's going to have an unallocated space out there until we can allocate it. And it's all about how this parity drive, it's all about how that it uses the data, the way that it maintains the data, which allows us to go way beyond, per se, the size of our disk, and allows us to create other volumes inside of here. This would be shrinking a volume on the primary partition. It's something that you cannot do with this, as far as shrinking a RAD disk. But if we wanted to shrink our initial small volume here, we could. Okay, now we're going to delete, going to detach. We know we're detached. It allows us to delete it. We're going to add a disk to our pool. Which we can see over here. Now we have 4. going to, inside of our pool, create a 16 gigabyte parity drive, increased reliability, reduced performance, must have at least 3 disks or you will get an error. This time we're going to use all of the storage in the pool equal to the volume size. And we're just going to click here, maximum. We are extended to our maximum size. We're going to look at our volume here. Allows us to create a volume. All we have left, the rest is mirrored through RAD, and everything is extended to its maximum size. Now we're going to move on to use PowerShell to delete the parity drive and storage pool. So we're going to pull up our PowerShell. First we're going to get command it shows us our pool that we created inside of our Prime server pool. So now we're going to delete. First, before we can remove this pool, we have to get rid of our disks or it gets an error thrown. So we're going to just detach that, go back into our PowerShell, remove virtual disks, and it's our 16 gigabit. Yes to all. Now we want to remove our storage pool. And we named it pool. Now we'll go back to here. Refresh. And there we are. We're back to our Primordial server storage. And down here it shows these, which I would delete these. And we have all unallocated disk space. And that's it for our Lab 3. And again, my name is Michael Samuel Webb. That's a walkthrough of Lab 1, 2, and 3 on using the graphical interface disk partitioning system here in Windows. I hope you have a good day.